So in example 2, some candidate thinks that she has the support of 40% of the residents in a particular town. A researcher wants to test. We'll come back to what this 5% significance level means in a second. Test whether the candidate is overestimating the proportion of her support or not. So the first thing we need to do is we need to phrase this as a probability question. So here, this is basically saying she thinks that the probability of a random person supporting her is 0.4. So let's write down what the test statistic is then. So the data that we're going to get as statisticians to test this claim is this research is going to ask 20 people and count how many of them support the candidate. So X is going to be a random variable because it's random because we don't know what it is until the researcher conducts their survey, and it's going to be the number of people that support the candidate out of a sample of 20. And X is random because we don't know the 20 people that we're going to ask until the researcher actually goes out. So next we need to define a probability. So the probability that we're interested in here is the probability that a random person supports her. So let's say P is the probability that a random person supports her. So now we can write down our null hypothesis and our alternative hypothesis. So it's actually going to be easier to write down our alternative hypothesis. So the researcher wants to test whether the candidate is overestimating her support. If the candidate is overestimating her support, then we think that actually the probability that someone supports her is going to be less than the 40% that she claims. So we basically think that the candidate is not as popular as 40% of the people. So P is less than 0.4. And remember, the H1 will always be P is less than, P is greater than, or P is not equal to. And our null hypothesis is going to be that actually the candidate is correct in her assumption and that actually P is equal to 0.4. And an easy way of remembering which way around these are going to go, the null hypothesis is always P equals, and you can always find that in the question. It's the probability that's given in the question. And then you just need to work out for the alternative whether it's less than, more than, or not equal to. It's worth noting because you need to know this in the question, but I'm not going to talk about it too much. But if H0 was P does not equal to 0.4, then this would be called a two-tailed test. And I'm going to talk more about what a two-tailed test means in this in the next set of videos. But you need to know that for this exercise. Here, because we've got just less than, then this is called a one-tailed test. But the terms will make more sense on the next section. Now, part C won't make much sense until you do the next section, so you can stop the video now and miss out 5C and 6C on exercise 1. If you're interested, then you can have a look at C and work out what that means in the next part. So I'm just going to briefly explain what C is, but it will make more sense in the next section when we actually do a hypothesis test properly. So under what condition could the null hypothesis be rejected? So remember, rejecting the null hypothesis means that actually there's evidence to suggest that the alternative is true. Well, if we think that the probability is lower than 0.4, then X, the number of people who support her out of the sample of 20, is going to be low. For example, if in our survey no one supported the candidate, then we could definitely say that actually P probably isn't 40% and it's probably less than 40%. So the way that we are going to do these hypothesis tests is we're going to look at the significance level, and we're going to talk a lot more about this in the next video, but I'll give you a rough idea of what that 5% significance level means. So basically, small values of X support H1. If not many people in the survey out of 20 say that they support her, then we're going to say that reject H0. Well, here I've got the binomial distribution. X follows a binomial distribution with 20 trials because we're asking 20 people. And each trial, each person can either say they support her or don't support her. So if H0's true, so i.e. when P equals 0.4, then X is going to follow a binomial distribution with 20 trials, and the probability of success, someone saying that they support her, will be 0.4. Well, what this 5% significance level means is it tells us how small does X need to be in order to reject H0. So 5% significance level basically means we need to be in the final, or the left, 5% of the distribution to reject H0. Okay, so these values of X will be small enough if they're in the left 5%. By the left 5%, I mean the total probability in the distribution adds up to 1. So the bars within our rejection region here have to add up to 5%. Remember, the height of each bar, when I draw a diagram like this, represents what's the probability that a certain number of people support her in a sample of 20. So you can see that if H0's true and the probability is 40%, then the probability of these numbers of people saying they support her out of 20 is really unlikely. Well, we saw that 3 people supported her, so it looks like that's quite unlikely. So it looks like we could probably reject H0. What we're going to do is we're going to work out actually what's the probability of being where we are or to the left. What's that probability there? And if you work that probability out, you get 1.60%. So because that probability of being at 3, 2, 1 or 0 is 0.60%, we know that we must be in the left 5% of the distribution. So we would, in this case, reject H0. But don't worry if you don't understand this part, because we're going to go through it a lot slower and it will make a lot more sense in the next few videos.